section 7.4 on logarithms, also just known as logs. We currently know that 2 to the third equals 8. We know that 2 to the fourth is 16. But what x would give us 2 raised to the x gives us 12. We know that the answer should be someplace between 3 and 4, but we got to figure out how to do that. Okay, so we're trying to figure out the power position right there. It's probably going to be between 3 and 4. Well, how come? Because 2 to the third is 8, 2 to the fourth is 16. I'm looking for 12. 12 in between 8 and 16. That means my power should be someplace between 3 and 4. So how do I try to solve for that variable up in that exponent position? We have to be able to undo being raised to a power. That undoing process is called a logarithm, and the shortcut word for that is log. So here's 2 forms that you definitely want to write down in your notebook. The exponent form that we're used to seeing is right here, b to the x equals y. Transform that into log form. Looks like this, log base b of y equals x. So the base, which is your b, becomes the subscript base in the logarithm. And then log base b of y equals x. So this is our way to get our x out by itself. The exponent here then ends up being on the other side out by itself. And we have just been able to solve for that x. So on this page, this slide, all I've done is a back and forth of changing things from exponent form to log form. So you might want to write these in your notebook in this same 2 categories, with exponent form on the top of one category and log form on the top of the other category. So again, here's our model that we're going to follow. B raised to the x equals y would then become log base b of y equals x. So the samples that we're going to go to are very simple samples. These are with numbers that we are already familiar with. This first one, 2 to the third, flashcard number, 2 to the third equals 8. What does that look like if we change it into log form? Well, remember the 2 is your base, so it's log base 2. Then we go to the answer number, which is 8. Log base 2 of 8 equals, and then here comes the exponent, which in our case is 3. So we were able to get our exponent out by itself. Log base 2 of 8 equals 3. 4 to the 0 equals 1. We know anything to the 0 power equals 1 in its log form. Log base 4, we're in base 4, log base 4 of the number 1 gives you the exponent. Exponent is 0. 12 to the first, we know anything to the first power is just itself. In log form it becomes log base 12 of 12 equals 1. Now on these next ones we're going to go backwards. It is written in log form. We're going to take it back into the exponent form that it came from. You want to identify the base first. Log base 3 of 81 equals 4. Start with your base, and then the number on the other side is the exponent. 3 to the fourth equals 81. You should be writing something that you now recognize as a flashcard number. 3 to the fourth equals 81. Log base 7 of 7 equals 1. Here's your base. Here's your exponent. 7 to the first equals 7. Yes, that makes sense. And the next one. This one might not make sense when you look at it at first. Log base 1/2 of 32 equals -5. 1/2 raised to the -5. Does that equal 32? Well, let's just think about that for a second. Anything raised to a negative power says to flip your base. If I flip my base 1/2, it becomes 2/1. And then it's raised to the +5. And yes, 2 to the 5th does equal 32. So that does make sense. 1/2 raised to the -5 equals 32. I am not a coffee person. Can't stand it. Special log properties. We're going to end up with about 9 of these properties eventually, so you definitely want to make special note of these properties. First one, log base b of 1 equals 0. How come? Because if we were, remember, if we were to change this into exponent form, b raised to the 0, b raised to the 0, anything raised to the 0 is always equal to 1. Your second special log property, log base b of b equals 1. Any log base of itself is always equal to 1. And again, why? Well, think about what this looks like in its exponent form. B to the first, this is your base, here's your power, b to the first. Well, anything to the first power is always just itself. So let's look at a couple examples. Log base 7 of 1, that follows rule number 1. That means your answer is going to be 0. And if you're not sure, check it. Check it into exponent form. 7 to the 0, does that equal 1? Yes, anything to the 0 power is 1. Log base 8 of 8, any base of itself. Rule number 2, answer is 1. Next one, log base 12 of 1. That takes us back to rule number 1. That answer is 0. And log base 3 of 3 is 1. How can we evaluate expression without using a calculator? A couple steps that we're going to use listed over here on the right. First, we have to make it an equation. Then we change that to exponent form, so from log form into exponent form. Then we try to get bases to match. There's a logarithm rule that says if you can get bases to match, the tops are then equal to each other. The powers will then be equal to each other. So we're going to go through this example right here. Log base 3 of 81. I want to figure out this answer. Step number 1 says to make it an equation. When you make something an equation, all you're going to do is set it equal to x. So we're setting it equal to an unknown piece. This is what we're trying to solve for right here. Set it equal to x. Step number 2, change it to exponent form. We've had log base 3 of 81 equals x. Changing that into exponent form, your base is 3, so it becomes 3 raised to the x equals 81. Step number 3, get your bases to match. We know that 81 also comes from 3, so write it that way. 3 to the x is the same thing as 3 to the 4th power. And then we go to step number 4. Tops are equal to each other, so you have this rule. Anytime you get your bases to match, 3 and 3, bases match, tops are equal, your answer is x equals 4, x equals 4, and we should be done. So this value, log base 3 of 81, is 4. We have 2 examples on this page. We're going to try to evaluate without using a calculator. And again, your option here is to try to get your bases to match. All right, so for this first one, remember step number 1 is to set it equal to x. You make it into an equation. Log base 1/4 of 256 equals x. Second step, switch this into exponent form instead of log form. Your base is 1/4. 1/4 raised to the x equals 256. Now we need to try to get bases to match. 1/4 and 256. Each one of these numbers comes from 4. 256 is 4 to the 4th. That's a flashcard value. We've got 1/4 to the x equals 4 to the 4th. These are not quite the same bases because this one on this side is 1/4. I need to get that back upright again so it also says 4. The way I can do that is to flip my 1/4 upside down and make it a negative power. So let's just think about this for a second. If I were to normally give you 4 to the negative x, and we know that we can't keep negative powers, we would take our 4, flip it upside down, and then make it 1/4 raised to the positive x. So we're doing the exact reverse of that. We're starting with 1/4 to the x, and I'm taking it back upright again. When I flip it back, I have to bring in the negative sign. So I went from 1/4 raised to the x, flipped back up again to be 4 raised to the negative x. Now my bases match. My tops, my powers can now be set equal to each other. Negative x equals 4, and I don't want negative x, I want positive x. So divide out negative 1 on each side. This answer, negative 4. Log base 64 of 2. Here's our next one. All right, so step number 1, we make it into an equation. Log base 64 of 2 equals x. Now I take it into exponent form. 64 is my base. 64 raised to the x equals 2. 64 does come from 2's, so I'm going to change it so I can get both of these bases to be from 2. Right now I've got 2 to the first. I need to change 64. 64 is 2 to the 6th. 2 to the 6th, then raised to the x. Power property lets me just write this as 2 to the 6x equals 2. Now my bases match. My tops can be set equal to each other. Tops are 6x equals 1, and I can solve for x. X equals 1/6. So log base 64 of 2 has a value of 1/6. Common logarithm is anything using base 10, and we're going to use the log key on our calculator. If you look on your calculator, far left-hand row, you're going to see it over there. And then the natural log is anything in base e. Natural log, log base e, is just written this way, ln, natural log. And we have a separate natural log button on our calculator as well. So these last two examples, all we're going to do is evaluate the logarithm or the natural logarithm on our calculators. So this first one is the log of 0.85. I'm going to pull my calculator up real quick here. Logarithm button is right here, far left-hand side. Okay, over here, far left-hand side, logarithm button, and then we are doing 0.85. You can close your parenthesis, just hit your enter button, and you should get negative 0.0705. And then the other question, I believe, was natural log. Let's just look again real quick. Natural log of 22. Calculator again, natural log is on the far left side, third one. Natural log 22. You don't even have to close your parenthesis here since we're just doing natural log 22. You could hit your enter button, 3.09. Okay, so those questions, I'll come back to my screen. Those questions, these are approximate values. You're going to be rounding these. I think this first one was negative 0.071 and then 3.091. Okay, so very simple questions on your calculator evaluating logarithms. And I believe that's it for now. Okay, so the one thing that you want to remember, the real big thing here, is that when you're evaluating an expression, you always make it into an equation first. Get your equation put into exponent form, get bases to match, and then set the tops equal. And then, of course, the simple rule of going back and forth between exponent form and log form. Okay, that's it for section 7.4. You can go ahead to Skyward and do your online little 3 questions.